Hi everyone. I'm excited to present SemLayer, our work on semantic-aware generative segmentation and layer construction for abstract icons. This is joint work between UC San Diego, Adobe Research, City University of Hong Kong, and the University of Toronto, appearing at CVPR 2026. Icons are everywhere, on the web, in apps, in design systems, but once they're exported as flat images, their layer structure is gone. Without semantic layers, designers cannot recolor the sun separately from the cloud, restyle individual parts, or animate them. SemLayer takes a flattened icon and recovers its layered, editable structure, so a designer can drag the sun to the top left, or paint it red, while leaving the rest of the icon untouched. Recovering layers from a flat icon is hard for 4 reasons. First, structural ambiguity. Many different curve parameterizations produce the very same silhouette, so there's no unique structure to recover. Second, semantic degradation. Flattening strips away color and labels, the cues we normally use to identify meaningful parts. Third, hierarchical fragmentation. A single object, like a tree, can be split into multiple disconnected visible pieces by occlusion. And fourth, occlusion order indeterminacy. Even after we recover the whole shapes, the original front-to-back drawing order is unknown. Formally, we decompose a binary silhouette into visible masks, then amidal shapes, then ordered vectorized layers. Our pipeline addresses these challenges in 3 learned stages. First, a generative segmentation model produces visible part masks. Then a completion model recovers each part's full amidal shape behind occlusion. Layer ordering then sorts the parts into a proper stack via integer linear programming. Finally, curve reuse and vectorization turn the result into editable SVG layers. Each stage directly targets one of the challenges from the previous slide. For segmentation, we found that classical segmenters like SAM and SAM2 confuse thin strokes with filled regions on abstract icons. So we reframe segmentation as controllable colorization. We let a diffusion transformer paint distinct colors onto each semantic part, while strictly preserving the silhouette. We build on the easy control backbone and train with the flow matching loss on triplets of prompt, silhouette, and colorized target. At inference, we threshold the colors into connected component masks. As you can see on the right, our method significantly outperforms SAM2 and GPT-Image1, reaching 84.3 MIOU and 76.1 panoptic quality. Each visible mask is only a fragment of a part, so we need to recover its full, occluded shape. We build on Pix2 Gestalt, a latent diffusion amodal model, and fine-tune it on our icon domain dataset to close the substantial gap from natural images. A key trick here is many-to-one fragment training. We feed disjoint visible fragments that all share a single ground truth target, so the model learns to merge them into one whole shape rather than completing each piece separately. At inference, we use an IOU-based merge with threshold 0.7. We outperform MP3D by a wide margin, reaching 85.2 MIOU and almost halving the chamfer distance. Now that we have the complete shapes, we need to decide which one sits in front and which stays behind. We formulate this as an integer linear program. The objective rewards orderings where each completed but hidden region is properly covered by the parts above it, while keeping originally visible regions exposed. In simple terms, it finds the most reasonable top-to-bottom stack so the final icon looks natural and remains editable. To train these stages, we built 2 new datasets. SemLayer segmentation contains 8,567 training samples, 4,920 curated real icons combined with 3,647 synthesized via GPT-4o and GPT-Image1. SemLayer completion has 50,000 occluder object pairs, each with paired visible and full masks, built via parallelized rejection sampling to ensure realistic occlusion patterns. Here are qualitative results across diverse categories: a mango, a cow, a covered dish, a delivery truck, a trowel. For each input, we show the segmented parts, the completed shapes, and the final layered stack. Compared to the reference layers on the right, our reconstructions closely match the intended layered structure. Recovering semantic layers unlocks entire creative workflows. Once SemLayer produces editable layers, the icon becomes a structured asset. It can be described in language, opening the door to SVG understanding. Users can swap colors on individual parts, scale a checkmark, or rotate a wrench independently. And because each layer moves on its own, the same asset can be animated. Wings flapping, wheels bouncing. What started as a flat black silhouette becomes a fully editable, animatable design. Thank you for listening. For more details, please visit our project page.